Hello folks, we come to the exercise 1.3 and we are taking up the part 2 video now. We are continuing with that FOG GOF which we did in the question number 3 subpart number 1. We did about the FOG and GOF, so we'll just continue with that. Let's see. FOG at x, f of g of x. So that is x raised to 1 by 3, that is g of x, and f of x is whatever comes here is 8. First we write 8, then we write the bracket term, and then we raise it to 3. So like that will come to 8x, because 1 by 3 into 3 will make it x raised to 1, and this will become 8x. Same way, let's find g of f of x. So g of f of x is g of f of x. F of x for us is 8x cube. And g means you have to take the cube root. So 8x raised to 3 and its cube root. Basically that is 2x. So we have got both FOG and GOF. That is what they have asked us. Now we move to the question number 4. In the question number 4, they give us a function which is defined like this. They ask us to show that FOF of x is x, and we have to also find the F inverse. That's a question. So let's start right away. Consider FOF of x, which means it is f at f of x. So 4x plus 3 by 6x minus 4, and what is the definition? We apply this definition. 4 times 4x plus 3 by 6x minus 4 plus 3 by 6 times 6x minus 4 minus 4. Okay, we'll have to equalize this. So let's equalize this by multiplying 6x minus 4 both to the numerator and denominator, and 6x minus 4 both to the numerator and denominator. So we'll have 4 times 4x plus 3 plus 3 times 6x minus 4 by 6x minus 4, and 6 times 4x plus 3 4 times 6x minus 4 by 6x minus 4. So we can have it cancelled. And now let's open this. 4 4s are 16x, 4 3s are 12, 6 3s are 18x minus 12 by 24x plus 18 minus 24x plus 16. Yeah, what we have done, we have opened the brackets. Now incidentally, in the numerator plus 12 minus 12 cancel, and in the denominator plus 24x minus 24x will cancel. So we are left with 16 plus 18x, which is 34x. Yeah, and this is 16 plus 18, 34, which is x. So what we have got, FOF of x is x. Whenever you get FOF of x as x itself, that is identity. Actually, this is the meaning is identity of x. Therefore, F inverse will be F. Yeah. For any expression, suppose if GOF of x is x, then G will be F inverse, like that. So here F inverse is F itself. That's what they've asked us. What is F inverse? Okay, next one is a very interesting question. They give you a lot of examples and say which of the functions have inverse. Now first of all, that function will have inverse which is bijective. Okay, every function which is bijective only will have an inverse. So if it has to be bijective, it has to be 1 to 1, it has to be onto. These two things have to be satisfied. So from the function we will decide whether it is 1 to 1 and onto. Once it is 1 to 1 and onto, it will have an inverse. If it is not 1 to 1 and onto, it will not have an inverse. That's all. So let's start right away with the first one. I think it's better if we plot it like this, becomes more clear. This is a function f, which is having codomain and domain as 1, 2, 3, 4, and codomain as 10. 1 goes to 10, 2 goes to 10, 3 goes to 10, 4 goes to 10. Many to 1, not 1 to 1, right? So here 1, 2, 3, 4 has image as 10. Therefore, f is not 1 to 1. Therefore, F does not have an inverse. Right? That's about the first one. Let's take the second one, G. 5, 6, 7, 8, and 1, 2, 3, 4. 5 goes to 4. 6 goes to 3. 7 goes to 4 again, and 8 goes to 2. It is not 1 to 1, not on to. Why? Because this 1 is remaining unrelated, first of all, so it's not on to. Then second thing, 2 things are going to 4, right? So that is not possible. So we can say here 5 and 7 has image 4. So G is not 1 to 1. Also 1 belonging to the codomain has no pre-image. So G is not onto, not 1 to 1. G does not have an inverse. Okay, so it doesn't have an inverse. Now let's take the H and let's see how the H is. 2, 3, 4, 5, 7, 9, 11, 13, 2 to 7, 3 to 9, 4 to 11, 5 to 13. It is 1 to 1, it is on to. So it will have an inverse, right? It is clear that H is 1 to 1 and H is on to. Therefore, H has an inverse. They have only asked us whether it has an inverse. Let me see if there is anything else in the question. State with reason which of the following will have inverse. So this is how it is. Now it is a 1 to 1, on to, wherever it is, it has an inverse. Not, if it is not, it will not have an inverse. That's all about this video. With more problems, we are coming in the next video. Thank you.